Hello there, guys, and welcome to your uh, another episode. I'm not sure. I think this is the third one, but I'm not gonna say the numbers because I'm gonna get confused eventually. Of interesting conversations with Mislav Jurić, and today we have a guest, Daniel Barrett, which you can see right here on the screen, and we are going to talk about very interesting stuff. So, first, to give you just a little bit of context about how I kind of met Daniel. I mean, we didn't meet in the physical world, but like in the virtual world. So essentially, I was working on this Linux tutorial series, and as one of the books, I was using the materials from Dan's book, which covers the Linux command line. And I invited him to the other podcast of mine, which is called Linux Stories. And then Dan came along. We recorded a podcast, but I thought he was really interesting because during his podcast there, he mentioned a lot of stuff like he was working in academia, he was working in startups, he's currently working at Google. So he has a lot of experience across the board, both in academia, in the industry, and in the startup world. So I thought it would be very interesting to have this conversation. So welcome, Dan, and maybe you could share a couple of words about yourself for the beginning.
Sure. Thanks, Mislav. It's fun to be back speaking with you again. So again, my name is Dan Barrett, and I am a software engineer and a technical writer. I've been working in industry for a couple of decades and uh, wrote several O'Reilly books, one of which Linux Pocket Guide Mislav came across. And right now, as you said, I am a senior manager at Google working in the education space.
Awesome. So could you kind of give us a tour through your career, kind of like historical, kind of where you started and what led you to this moment in life? Kind of how did your career lead you to this point?
Okay, so I guess I'll start at college because before that I had jobs like being a magician at children's birthday parties, which was a lot of fun, but not relevant to our conversation today. So I went to undergraduate university at University of Pennsylvania, where I studied math and took some computer programming courses along the way, which I thought was a lot of fun. So I thought, hey, when I'm done, maybe I should go to graduate school for computer science. So from there, I went to Johns Hopkins University, where I started out in a PhD program, got my master's, and then decided I wanted to take a few years off. So at that point, I became a computer system administrator at Johns Hopkins Computer Science Department. I took care of their dozens of Unix workstations from Sun Microsystems and Digital Equipment Corporation, a lot of names maybe you don't hear so much anymore, but they were top of the line at the time. I also started teaching there. I taught undergraduate computer science courses for a few years. And after a couple of years, I went back to graduate school, this time at University of Massachusetts in Amherst. And I got my PhD in computer science there and software engineering, particularly around how computer programs in different programming languages can interoperate with one another. This was in the early days when there were no REST web services. Actually, there was no web. So things were a bit harder when you had multiple programming languages. After graduate school, I thought I was going to become a teacher. That's what I wanted to do. Nice little, bearded professor at a liberal arts college somewhere. But instead, I wound up going into the financial industry, where I worked for about 5 years, starting off with building software to allow people to trade stocks online. This was before that all started. And I worked at a company called D.E. Shaw in New York, where their goal was kind of in the same way that when you go to a bank and you use the ATM machine, there's a company that builds ATM machines. The bank doesn't build them. So D.E. Shaw, this was a little bit of a startup on the side of D.E. Shaw, wanted to be the ATM manufacturer for stock trading websites. So various companies would buy the software and be able to let their clients trade stocks. That went on for a few years, and then my part of the company was purchased by a much larger financial company called Merrill Lynch. I worked there for a few years, and that ended when the dot-com crash happened at the end of 2002 or thereabouts, and we were all suddenly laid off. I was out of work for a few months, and then I was with my daughter at the time, who was about 2 years old, at a children's gymnastics class. This is relevant. When one of the other fathers next to me said, "Oh, Dan, I heard you lost your job. Have you ever heard of Vistaprint?" I said, "No, I've never heard of Vistaprint. What's that?" He said, "It's a company that makes business cards on the web." And I thought, that sounds really boring. So I thanked him. But he said, "No, actually, I have a friend who works there with a PhD in cognitive science, and he loves it." I was like, "What? What are you talking about?" So I interviewed there and wound up staying 15 years. Um, Vistaprint being now a much larger company than it was at the time, doing all kinds of e-commerce and manufacturing, business cards, holiday cards, T-shirts, and thousands of other products. So that was a lot of fun getting to go through that whole process, which I'm sure we'll talk more about. After I left Vistaprint, actually, while I was there, I got into education quite a bit because the company was growing and new software engineers needed to be trained. So I was tasked with the problem of how do we keep doubling in size every few years and make sure all the engineers know what to do. So that sparked an interest in education and industry. And when I went to Google, now I'm getting to do the same kind of thing on a scale 10 times larger. So that's where I am now.
Awesome. Yeah, that sounds like a very interesting career path. So I heard you mention you went to grad school. Um, did you so when in America? I think America is different from Europe here. In America, I think you do a bachelor's degree and then you go straight from the bachelor's degree to a PhD. And if you drop out of a PhD, then you're just like a master. Uh, I don't know if I understand it. So essentially, what I wanted to ask you more about is your academic experience. So when you went for a PhD, what was it like, and for what reasons do you think someone should try to do a PhD?
Okay, great questions. And there's a lot to unpack in what you just said. I'll start with the first thing you mentioned, which is how it works in the United States. After a bachelor's degree, you can go for a master's degree or directly into a PhD program. Traditionally, if you go directly for a master's, you wind up paying for it. And if you go directly to a PhD, the university will give you a stipend and so forth. So, and they'll take care of tuition. So a lot of people will enter a PhD program, and along the way, many of them will earn a master's degree. It doesn't really matter whether it's not directly related to whether you leave or not, but it is true that some people leave after their master's, even after they have entered the PhD program. So I went to graduate school for all the wrong reasons. I was completely clueless. I went because I had taken a couple of computer programming courses, and I thought, this is fun. I'd like to do more of that. And I wasn't really sure what kind of job I wanted. So I thought, well, maybe I know school. I've been doing school for my whole life. Let's just stay in school for a little longer and I'll do some programming. Oh my God, was I wrong? Because as I'm sure you know, Mislav, computer science is not all programming. There's a lot of theory. You've got abstraction. You've got automata theory, compiler theory, operating systems, all this kind of stuff. I had zero experience in any of it. I was good at math, as I had majored in that, and I had taken one or two courses beyond that, but I was completely unprepared for graduate school. I didn't even know that people went to graduate school to write research papers. I knew nothing. So I got there my first year, and I was like the worst student. I tried really hard, but everybody knew more than I did. And I remember going into a graduate seminar, my very first one, where everybody would read a paper and then have to present it for the class. And I didn't understand any of the papers that any of my classmates were presenting. And every time the professor called on me, I would not be able to answer. And I actually saw his face was just exasperated with me, and he was really tough. So when it was my turn to present, I must have worked for 2 weeks to understand this paper, just heads down. And I wound up doing okay. And the professor was really surprised. So I think that's what kept me there after a very, very discouraging first semester. I gradually learned what I needed to know, and that was fun. So the right reasons to go to graduate school, I think, are number one, you should be really interested in research, and number two, you should be passionate about the subject area in a sense that you read about it for pleasure, and maybe even you've thought of a question that you'd like to answer that nobody else has answered before, because that's what a PhD dissertation is all about, asking a question that no one's ever answered, and possibly for the only time in the remaining part of your life, you get to do nothing but work on that question. So you really have to be self-motivated. You have to be willing to tolerate long stretches of no progress, of ambiguity and little feedback. But it is a free opportunity to pursue a passion in a way that you usually cannot do in industry unless you happen to work for a very small number of companies where they allow that latitude that latitude to their researchers. So I'll pause there.
Yeah, I mean, that sounds like something that's very similar to what I did. So here in Europe, usually, I mean, at least in my country, it's usually like customary to do both the bachelor's degree and the master's degree, because the bachelor's degree is 3 years, and then you have a master's, which is 2, and then PhD is 3. So that's how it works in Europe. So I minored in information systems, which is somewhat similar to computer science, but not really. And then I went to graduate school for computer science. And so I had a regular computer science grad coursework, but I also had difference exams, which included, just as you mentioned, automata theory, artificial intelligence, computer graphics, etc. So, and I completed it all in the span of 2 years. So all of the normal grad subjects plus the differences. So that was pretty difficult. But when we're on that topic, I just wanted to ask you, what do you, so you said that you minored in math and then majored in computer science. What were the most useful math subjects that you had that you're still using? So like if you had to pick just a handful of subjects that were really, really useful for you in your career, what would you pick? Which subjects?
Great question. Just for clarity, I did major in math as an undergraduate, but then computer science for grad. I would have answered your question differently a few years ago. I would have said graph theory and combinatorics. Those are the two topics that are most useful. Graph theory being the study of relationships among abstract objects, and combinatorics being the mathematics of counting things, which is a very short way of introducing something that's actually extremely complicated. But they're both examples of discrete math, and meaning integer math, and that seemed very valuable to me for many years as an engineer. But today, with the rise of machine learning and data science, I would say calculus and statistics are going to be your best friends. You should still have graph theory and combinatorics. They're invaluable. But I had to remember my calculus from many years ago as soon as I got to Google, because there's so much machine learning going on, and I had forgotten quite a bit of it because I didn't ever use it. But now, understanding what a regression is, remembering derivatives, all that kind of stuff, maxima, minima, continuous functions, very important now.
Yeah, so just to kind of dig maybe a little bit deeper. So you obviously work at Google, which is a which I think is a company that almost everybody wants to work at, because it's very famous for offering high salaries and a very great work-life balance and all kinds of very good stuff for the employees. So, what I would say, what level of math? So you just listed the subjects, but I would say, like, to what level do you need to know them? So, for example, is it enough to know how to take a derivative of a certain function, or, for example, should you be comfortable with proving everything in a math book? If you understand my question. So, like, how deep do you need to go in those subjects? Do you need to be comfortable with, like, the basic terms and, like, basic derivatives, integrals, etc., or you have to, like, be able to basically prove theorems, almost all of the theorems you see in a book? Like, what would you say?
Yeah, it really depends on what part of the company you're working in. If you're trying to develop something really new in a research arm of a company, then um, the deeper knowledge that you were describing would be certainly necessary. Um, However, just for working within machine learning and data science, if you just have the basics of regression and understanding how to find maxima and minima of functions and gradient, things like that, if you have those basics, you're going to be fine. And if you need to learn more, you'll learn more that in order to do your job. But I know when I started learning about machine learning, I really had forgotten a lot of that stuff. And so it was painful at first, not only just learning it again, but the embarrassment of, I know I used to be good at this. Ah! So yeah, the basics are fine for getting started.
Yeah, yeah. Uh, so another question I had for you is, you said you worked at this virtual business card company. I forgot its name. I apologize, but essentially you worked there for 15 years, since they were a small company and today they're really big. So could you describe your experience there? And so, like, could you just describe, like, the startup experience in general? Like, how does your week, typical work week, look like? What do you work on? Is it very dynamic? Is it very, like, is there a lot of work always? Do you always feel, like, stressed out? Like, just kind of describe the typical week there.
Mhm. Yeah, startup environment. I mean, and I've only been at two startups, so that doesn't necessarily describe the whole spectrum. Um, but the idea of a typical work week and a startup, those two things don't go together. Uh, when you work for a startup, there's a tremendous amount of variety in your day. When I started at Vistaprint, there were about 80 people in the company. Just for perspective, when I left 15 years later, there were about 12,000 in 40 offices in 25 countries. I mean, it was a gigantic hyper growth experience. But at the very beginning, I was brought in to write software and to manage software projects. My first project, in fact, was to look at the existing software base, which was all written in VB script and Visual Basic, and yet was serving customers, and manage the transition of all of it to .NET. And that was a strange mix of furious programming and architecture, because I had the chance to do something that hadn't really been started yet. So how did we want to refactor the code base in order for it to take most advantage of a more modern programming paradigm? And so my typical days at the beginning were come in at some early hour and program heads down until late at night. And it was great fun because there was really rapid feedback. We had a development environment and a test environment, and you could make changes really quickly. And what was wonderful, and this is in general true, I think, of startups, is that it's very easy in a small company to have a big impact. When I and a few other engineers wanted to solve a problem, we just figured out a solution and did it. And there was nobody, standing over us saying, no, you can't do it that way, or we need to think about other factors. No, we just did it. And this is one of the most satisfying parts of the startup environment, which is it's that influence. As long as your ideas are good and they work. You also have to have a high tolerance for failure, because sometimes your brilliant ideas turn out to be terrible ideas, and then you can't lay down and feel depressed. You have to try the next thing. So at the beginning, it was a lot of programming, and we would do our software releases in the middle of the night, once every 3 weeks. So I would have to come into the office at 2 in the morning, because most of our customers were in the United States, and we didn't want our servers to be down for the upgrade while they were using the site. Later, that no longer worked as we were more internationally used. So yeah, I bring a sleeping bag into the office. I work all day, and then pull my sleeping bag into a conference room and sleep for about 5 hours, wake up just before the release, and run it. So that was very interesting. Another aspect of this is there were a lot of rotating roles. In a startup, you have to wear a lot of hats. So for 6 months, I was the main release manager to make sure the software got out to production. But at other times, there were other rotating roles, handling problems, carrying a pager. Yeah, lots of stuff. I also got very involved in recruiting, evaluating resumes, bringing in engineers, coming up with interview questions, and writing lots of documentation. So it was just tons of stuff. Your job title is like the do everything person for most of the people there. So that's a lot of fun. I didn't feel a tremendous amount of stress. You mentioned stress. I think it was mostly fun. Then again, psychologists are aware that we kind of idealize the past when we remember it, and we don't remember the bad parts quite as well sometimes. But it was a tremendous experience. Everything changed as we got bigger. When you're 100 people, you know everybody. When we got to be 1,000 people, it's a little harder to know everybody. When we got to be 3,000 or 4,000, it was very hard to find the person you wanted when you needed an answer. And as we approached 10,000, well, at these various milestones, the company had to reinvent itself. Sometimes we were structured by skill. The software engineers were over here, the testers were over there, the IT people were over here, the marketers were over there. Then other times we structured by geography. The part of the company serving the US was over here, the people responsible for Europe were over there. Then other times we refactored into small teams or squads. So a single squad might have a marketing person and 2 software engineers and an IT person and a tester, and you would take on projects as a little mini company. And we restructured every year and a half, I would say. And this is one of the reasons that the company did so well and survived for so long. About 5 years after I got there, we went public, and then now Vistaprint is a medium-sized company, several $1 billion a year in revenue. So yeah, there's a lot of excitement.
Yeah, that does sound like a lot of fun. So I have a question for you now that is kind of the comparison between startups and academia. So what do you think are the similarities between those, and what do you think are the differences between those?
Okay. I would say one strong similarity is you have to be really self-motivated. In academia, you're working on the research, sometimes completely by yourself, sometimes in a small team, but there's no boss standing over you. You make your own schedule, you do it all. And in a startup, it's very similar. You have to be very self-motivated. Nobody has time to stand over you and make sure you're doing what you need to do. Everybody's got their mission. You just have to do it, and you have to tolerate long periods of ambiguity as to even whether the company will survive the next month. So that's something that's similar. I think also another thing that's similar is how you have to think about failure. If failure just crushes you, you should not go to a startup or into an academic job until you learn to treat failure more as an opportunity. A failure means that something that you tried didn't work. So what are you going to change to try to do it better next time? What can you learn from it? Very, very important. I think that's also important in big companies too, but in particular in academics and in startups, you really have to learn from failure fast and move on from it without feeling too upset about it. So that's an area where I'd say they're similar. For differences, I would say academia, I mentioned this before. If you have an idea of what you want your life's work to be, like, I want to go out there and do this one thing. Academia may be a good channel for that because you have that very self-directed environment where you are judged based on your output and the ideas that go into that output are pretty much all your own. Obviously, you learn from other people, from other papers you read, and so forth. But if you have this singular goal and you have the passion to pursue it, academia can be a good place for it. There are some, I guess, disclaimers to that because when you're an academic, you are basically running a small business all by yourself. You might be running a lab. You're definitely chasing money. You've got to find funding, which is very time consuming and frustrating. You might have an idea and not be able to find funding for it for 2 or 3 years. Very frustrating. And you might be supervising people. So it really is like running a business. And if you've never run a business, you go into academia, a lot of this can be pretty shocking and difficult. So that's one challenge of academia. And then in startups, I think one really good thing about a startup I mentioned is having that big impact, wearing lots of different hats. And also, you really have to be willing to accept greater risk in order for potentially higher rewards. Like, you don't know if your company will be around in a year. Most startups, I understand, fail in the first 4 years or so. I've heard statistics anywhere from 50% to 90% for startups. So you need to tolerate that risk. And that can be hard if you, for example, if you have a family and other people are dependent on your paycheck. But if you're young and single, a startup might be a great place. Even if it turns out to completely bomb, you will learn something. You will absolutely learn. And that will come in handy later. So I think it's a little bit of a cliche that startup lifestyle is for the younger, but it's not particularly true. But when you are younger, you may have fewer ties, fewer responsibilities beyond yourself. So the risk is all taken on by you instead of by other people around you. So that's helpful.
Yeah, I think you described this very, very good. Yeah, and I agree with the fact that I think that the younger you are, and in general, like, the less responsibility you have, the more risks you can take. Because if a lot of people depend on you, then it's probably not a good idea to take a lot of risk. I mean, unless you're unethical or don't have any moral sense of obligation towards anyone, then I guess you can do anything for the rest of your life.
Yeah, we usually screen out the psychopaths during the initial interview.
yeah, but maybe a couple of them just fly by. Anyway.
You know, that would explain a lot. Oh, no comment.
Yeah. So I wanted to ask you another question, which is kind of tricky, but I'd really like to know your thoughts on this. Which one do you think is hardest to excel at? Is it academia, startups, or the industry? So we're talking about, like, really being truly one of the best in the world at whatever it is you do. Now, obviously, there's different types of research people do. Maybe somebody in academia is researching some stuff from graph theory. Maybe someone else is doing some artificial intelligence research. And obviously, there's many different startups and many different companies that do different things. But in general, like, if you were really hard pressed to answer this question, so what do you think is, like, the out of those three, so startups, industry, and academia, which one requires sort of the most work ethic and potentially even the most talent to like really be one of the best in the world in those? What would you say?
I think maybe what you're asking is if you really want to make your mark, startup, academics, or big company, which would be a direction to go? That is a complicated question because I think the world is filled with variety, and there's not one answer to that. But I can say a few things. In academia is a pretty tough road. Right now, in particular, when you join as an assistant professor on a tenure track, there's the standards for what will get you promoted have greatly increased over the years. It used to be the case that a vita or a resume that used to get you tenure 20 years ago, today will maybe get you a postdoc because everybody's they're coming into graduate school with already having publications, and they're coming into applying for jobs as a professor already having had, say, 2 postdocs in different labs. And so the level of competitiveness is very high. And this whole publish or perish, this idea that you need lots and lots of publications has really gotten crazy. My wife is an academic. She's one of the rare, extremely successful academics. She has an international reputation. And she has a real passion for trying to help the younger assistant professors because their situation is really hard right now. So you really have to want it. You have to love research. You have to tolerate ambiguity. And some people really make a mark there, but there's so many people out there doing so many things. It can be challenging. It depends what you want the scope to be. If you want to answer a big question, you may be able to do that. How many people will acknowledge you for it? That's the variable. So you have to take motivation from inside. When it comes to a large company, large companies have the resources to fund you to do great things. But there are many more eyes on what you are doing, a lot more objections, more politics, and so it's a trade-off. It's great to work for a company where if you need X number of dollars to do something, there are some companies that can just say sure. And then there are others, that are smaller or less well off that it's much harder. But compared to startups, the traditional company will have more money. And so in that sense, the opportunity to do the work is there, but you may face a lot of obstacles. If you succeed, maybe you'll produce Google Maps or Gmail or something like that, and that can be a little bit satisfying, right? Then with startups, they don't have the budget necessarily, but you can make change quickly, and maybe one of your ideas will be very successful. The thing is, your company may not survive, but will have a level of impact in that company that can be very satisfying while it's all working. So I guess if I were to sum up, the potential for like worldwide impact is, I thought I had something there, I don't. It's hard in all three. If it weren't, then there would be a lot more people having that kind of impact, but it's different. In academics, it's that idea of solving a problem no one solved before, but how much recognition you get for it may be very variable. In a startup, great opportunities for impact. That scope of the impact may be limited, but it may feel very satisfying for you. And then in a large company, you've got the resources, but you may see a lot of pushback and a lot of people trying to do similar things that you wind up in competition with.
Yeah, thank you for answering that. So I think we already touched upon these in this answer. Um, but I just want to ask it again, maybe if you'd like to add some details. So when you contrast academia, startups, and the industry, what would you say are the main reasons people should choose each one of those?
Hmm.
So
Hmm.
like
Yeah.
if this is more of like in terms of maybe a lifestyle or maybe some perks that they have in one over the other ones.
Hmm. Hmm. I would say for lifestyle, academia and startup are pretty similar. You're going to be working long hours. Most academics that I know that have any measure of success work 7 days a week and many evenings. So, um, and the rewards are really variable. But if you love what you're doing, then it can be worth it. So, if you're going to be an academic, you know, be prepared for that. Um, with startups, you'll also be working very hard and odd hours and so forth. Um, but a difference there is with a startup, your goal is usually a little clearer. You've got this business idea and you want to make it a reality. And that idea may shift around a lot, but there's sort of a core to it that remains the same. You know what kind of product you're going to produce or so on. And um, maybe it's a little bit easier to see where you are along that path. Whereas if you are following a line of academic research, um, you are not only the person doing the work, you're also the person who came up with the work. And so you may change your mind, things may feel less stable. Um, but you need to be someone who tolerates a lot of ambiguity, a lot of long hours without a lot of reward. With a more traditional company, you have the more stability, your responsibilities are better defined. You might be able to wear a lot of hats, but you might not have to. And there is, I'd say, more politics and more hierarchy. When you're at a startup, you can knock on the door of the CEO and walk in and say, hi, Jane, how's it going? Where if you're a big company, you're not going to knock on the CEO's door unless you're invited. So a lot more hierarchy, maybe more being told what to do. The companies that I've worked for have had a lot of flexibility. So, Google is flexible. Vista is very flexible. Um, when I was at DE Shaw, it was very flexible. Merrill Lynch was not flexible at all, but we tried to keep it that way, just in our office. So, but you do have more stability. You have a good idea the company's going to be around for a long time, hopefully, steady paycheck kind of stuff. So, is that answering your question?
Yeah, I think it is. Um, Thank you. And what I wanted to ask you, so as I already mentioned in the introduction, you have written several books. The thing that I didn't mention is you also have had a music career, and one of your songs is, I think, titled "Find the Longest Path," which is, I think, in the introductory or the ending lesson of one of algorithms courses in some of these online courses. So essentially, the question I had is, do you think that better writing skills and or better music skills can actually help people with software engineering or maybe computer science or math in general?
Mm-hmm. Mm-hmm. That's an interesting question. I'm not. I'm going to propose that it is not the right question. In that, I think that writing music and writing text and programming all are helped if you can think abstractly and clearly about something. So if you are, say, refactoring a big piece of code, you have to hold in your head what are the different aspects of that code, what are the different interfaces, and imagine a different universe in which you still have a working system, but it works differently than it used to. I mean, sorry, but it's structured differently than the way that it was. Um, when you are writing a book, for example, you need to take a big amount of information or a very large complex topic and break it down into pieces and organize them. And when you're writing music, music is a very abstract endeavor. You want to get across a certain feeling or a certain collection of sounds that you think will be good together because you can hear them in your mind. So all of these endeavors have to do with this ability for abstract thought to hold a lot of information in your working memory and to kind of think clearly and make clear separations between things that are not related and find relationships between things that are related. And those more basic skills, I think, will help you in music or writing or programming. So I imagine that if you have these kinds of skills and you practice software engineering a lot, you'll be a good software engineer. Or if you practice writing writing text a lot, you can become a good writer. Likewise with a composer. So not so much that the three have relationships among themselves. There's more about the core skills.
Yeah, that makes sense. And so my sort of final question for this podcast episode, which I kind of always ask, is do you have any parting thoughts to say before this episode ends? You know, we talked about like startups, academia. I think we really kind of dissected each and every one and talked about the differences and the similarities. Do you have anything to say maybe for the end that you just want to throw in?
Sure. I would say that if someone is listening now who is studying computer science in university or is in their first job, there is so much that you learn on the job that you do not learn in school. If you want to be a software engineer, for example, and you are a fantastic programmer, you can go heads down for weeks and produce amazing stuff. That's not going to teach you how to work with other people. There are skills that you have to pick up in industry, or if you don't pick them up, you will have trouble. For example, when somebody tells you something, whatever it happens to be, they tell you about a project or whatever. If you reflect back to them what you heard immediately, that's a skill. That tells that person that you understood what they said and that you were listening. That's not a skill you learn in college. That's something you learn in industry from working with a lot of people. Another big thing you learn in industry, you don't learn in school, and some people never learn this, is it's very rare for someone to come to you with a problem that needs solving. Now, you might disagree. It's like, no, people are always, they go to an engineer and they say, I need a video, an AI system. It's like, no, but they're not coming to you with a question. They're coming to you with a solution. Someone comes to you and says, I need a robot that drives a car. And the wrong thing to do is to jump on it and build a robot that drives a car. The right thing to do is to dig and find out what business problem they're trying to solve. Well, why do you need a robot that drives a car? Oh, because my driver is always sick, and robots don't get sick. Oh, why is your driver always sick? And then maybe you'll find out that really the underlying business problem is that there's a virus going around or something like that. It has nothing to do with robots. So find out what the underlying business problem is. Don't just solve the solution. Don't just provide the solution you're given. And so these are the sorts of things that are really, really important to learn that go beyond the subject matter of being an engineer. And so as you move into a job, keep an open mind. Find a mentor, somebody more experienced than you, and ask them, what do I need to know beyond my programming skills or what have you? And you can really grow. So I'll stop there. Yeah.
Yeah, that's great. Thank you for joining me. This was it for this episode. I hope you enjoyed it. And I hope it was fun for you as well, Dan. to chat. And yeah, that's it. Talk soon.
Okay. Thank you. Bye.